Hello again. In this chapter, we're going to talk about a potential problem in the Java code that we write called escaping references. This is actually a little bit of a side topic for this course. It's not directly about performance, but I want to cover it here because it is an important concept that I think all Java programmers need to know, and you can only really understand it when you know how objects are passed by value. However, if escaping references is something that you want to be able to avoid in your code, and you're concerned about your code's performance, knowing which strategies will have no direct performance impact will potentially be helpful. So as we talk through the different strategies, we'll also discuss their performance impacts at the same time. If you're taking this course simply because you have an existing application which you want to improve the performance of, then you can safely skip this section, although I would urge everyone to work through it as it will help you be a better programmer in the long term. I could perhaps have called this chapter Copying Collections because that's one of the things that we're going to be looking at specifically around performance. So maybe if you're interested in the performance aspects of copying collections, then this chapter is also going to be relevant for that reason as well. But let's start by understanding why escaping references are a problem, how to identify them, and then we can talk about the strategies we will use to avoid them. Now, if this is a completely new topic for you, then you'll probably realise as you study this chapter that you've written lots of code with escaping references already. And that's okay. The important thing is being able to identify when they occur and to understand their potential impact. Avoiding escaping references can be a lot of work, and many projects don't go to the extent of avoiding them, which is completely acceptable as long as you understand the risks. So let's start then by understanding what an escaping reference is. One of the key concepts of object-oriented programming is encapsulation. This is the idea that classes contain both the data and the functionality packaged together, with access to the data within a class being strictly controlled. Let's consider this simple book class, for example. I'd describe this as a well-defined class. What I mean by this is that the data in the class, which is the title and the author, these fields cannot be accidentally changed from outside the class. We've created them as private fields, so they're not visible directly, and we can only set the value of the fields by calling either the constructor or one of the set methods. In other words, it will be difficult for somebody to accidentally change the value of one of these fields within this class. We have tightly controlled the access to them. Let's have a look now at another example. Now here, the private field of our customer records class is a map of customer objects. We instantiate the map in the constructor of the class, and we have a method to add customers to the map, and all of that looks fine. But let's look at the final method here, the getCustomers method. The idea here is that we want to be able to access the records in the map for iterating, so we can write some client code that looks something like this. In the client code, I'm calling the getCustomers method so that I can iterate for all the customers and print them out to the console. Now, I hope that you're comfortable with this code. It's very standard Java code, and I've certainly written code like this a lot of times. But actually, what we've got here is not very good. There is a problem. And the problem is this getCustomers method. We now know that this returns a reference to the records collection. It means that the calling code now obtains a reference to the collection, and it can do anything it likes with that collection. For example, I could write code that looks like this. Here I've used the getCustomers method to get the reference to my map, and then I've called .clear on that collection. This has enabled me to remove all of the records from a customer's collection, which is not something the original developer of our customer records class would have wanted me to be able to do. They would have only provided the getCustomers method because they wanted me to be able to iterate through them. The author of customer records certainly didn't want me to be able to change the records by calling getCustomers. So the reference to the map has escaped from the class in which it should have been encapsulated. It's almost as though we've declared this map as a public variable. We have violated the encapsulation rules. The real pain of this kind of circumstance is that we now have a very difficult job in debugging. If we find invalid values in the records collection, or for example if that collection gets corrupted somehow, it's going to be really hard to find out where in our code did that data get changed, because any code anywhere in our project can now access and mutate this collection.